All right, welcome everybody. Today is the 21st of November, heading into U.S. Thanksgiving. And, this is Dallas Personal Robot Group. We're going to have our online talk, go through normal questions and robot-y things, share what we've done. Hopefully a little bit later on, we'll probably have more folk join who are at the contest that we just held a few days ago on Saturday. But until then, just welcome everybody. We have in queue so far, we have Ray, then Mike, then Jesse, and then open mic. So Ray, what do you have?
Okay, this is what it is. It's not light. Anyway, I've mounted, I've used some more of that channel stuff. And these are the two hoverboard brushless DC motors. This is my spacer, which is a piece of 4-inch plumbing coupler. That's going to go, on the top there, and then I'm going to have another rail that sits on top of that, perpendicular to the, this will be like that, perpendicular to the axis of the wheels, to get it high enough so I can use a larger caster. That was one of the lessons learned from using only a 3-inch caster. I can use a 6-inch caster now and, fit it under it, but not have it get stuck in ruts and stuff like that. So, that's going to be driven by 2 of these. It's a 3-phase brushless motor controller. So you've got PWM, direction, and a stop as control inputs, and it actually outputs more or less an encoder value, or I think it's actually used as a tachometer. You can measure the pulse width and figure out how fast it's rotating. It's kind of a logical OR-ing of all 3 phases. The 3 phases from the Hall effect sensors overlap a little bit, and so you've got 3 signals, A, B, and C Hall effects, and any of the 2 will overlap, and that's what produces a pulse out. Just during the overlap period. So I get 48 pulses per rotation, or 96 edges. It's pretty much a square wave. So I can use that as encoder counts. So it's not super fine resolution. I'd like the count to be higher, but I think I can get it to work. So basically, the PWM corresponds to a velocity. The controller takes care of all that. I don't think I'll need a PID loop. It seems pretty tight. You increase the duty cycle, and it spins up pretty quickly to whatever speed you want it to go. It'll rip right along on the ground, I think, between 6 and 7 miles an hour. And that's what they say it'll do. I don't know if it'll do that on level ground with a person on it or a heavy person. It may slow down a little, but it's supposed to be able to hold like 220 pounds on the hoverboard with those motors. So anyway, that's going to be my new outdoor platform. Learn some things about the front bumper. I think I've got to have like corners on the front bumper so sticks and branches can't get in behind the bumper when it goes into the weeds, because it got caught in the weeds, and the bumper was actually holding it back because brush had gotten around the ends of the bumper. So going to do a new style bumper that doesn't, basically doesn't stick out. It's probably going to be more like a Roomba bumper where the whole front of the thing is a bumper and it wraps around pretty close to the, center of the wheels. So, going to have an ESP32 on it. So that's, I'm kind of hopeful that'll overcome some of the limitations of, the platform from before, the small caster in the back, the bumper. It actually went twice as fast as it did last year. I can go 3 times as fast as the, last year. But kind of wanted to play around with the 3-phase brushless motors. Hadn't done anything with those before. I also have come on, let go. These are smaller ones, more for a 6-can or can soccer, size platform. It's got a 6mm shaft. I've got to get some wheel adapters. This one has a fairly nice heads encoder on it. I want to say, I think this one was 500 pulses. It's actually 3 channels. There's like a home pulse or 1 pulse per revolution, and then 2 quadrature or 2 tracks that form a quadrature. So, and it also has Hall effects. So with that, I can get very good resolution. I was thinking of mounting the wheel directly on the shaft. These will spin really fast, a lot faster than the hoverboard motors. I don't know if it's going to have enough torque. I'm going to have to just experiment and see what I can get it to do. I could put like a 5-to-1 sprocket reduction on it, on the shaft, and probably be able to boost the torque if it's too low. But they're all going to be driven by that same 3-phase motor driver. So that'll be kind of nice just to have the commonality between them. So anyway, it's going to be all things 3-phase brushless motors for next year. So anyway, that's all I got.
So it starts as a hoverboard, but you're going to add a caster. You're not going to do like 2-wheel balancing on the outdoor course?
No, too hard to do. Yeah, I got to have at least 1 caster on the thing. So
that's fair. Who can argue with that?
And I could 3D print some of the parts, but to just go to Lowe's and pick something off the shelf that's the right length and the right diameter, the plumbing stuff, it's pretty handy. And it would take literally hours to print something, that big and that sturdy. So
when weight is not an issue, right?
What's that?
When weight is not an issue.
Yeah, it does. The plumbing fittings are heavier, no doubt about that, because they're pretty thick. But it should also be very rigid. I don't know. I'd have to see what Paul had on his. He had a really fat caster on that thing, didn't he? Like 3 or 4 inches wide. And
yeah, it was a big wide.
Yeah,
not quite a ball, but it was a wide caster.
Yeah, I didn't see it. What diameter was it?
I don't remember.
No, okay.
There's a photo of it somewhere.
Oh, is there? Okay.
Mike's got
maybe 3 or 4 inches in diameter, maybe more.
Mike said it's this big.
That big, okay.
Well, didn't you get a good? I suspect everybody got a good look at it when they started mounting a cone.
Yeah.
Yeah, I was working on trying to add multiple waypoints and fixing things, and so I didn't really see much of Paul's runs.
Well, there are video.
You can see it in the robot interviews. I just put them up. They're up there, and I'm working through the run videos now. And Carl, here's the ones I have. So I'm hoping you have the other ones. And
Yeah, what?
Steve has some.
Yeah, I was going to ask if we coordinate, because we can do individual runs, or if you want, like, it might take me a little while, but I can merge them all together into one big file and segment them by time, like we talked about.
Well, you can do it that way. Either way, I've uploaded 2 of Ray's, I believe, and 1 of Paul's, and 1 of Scott's that I happen to have. 2 of Scott's.
Okay, I can just upload them all directly if you like.
Yeah.
Certainly easier.
Well, I put them in a, whatever they call it, a grouping, where they have all of the
Playlist.
ones for this playlist, right?
Yeah.
All of them are in a playlist.
All right.
But if you can do them all together, if you can take the ones that are up there and add them to it somehow, then I have no problem with it if you can do the chapter thing. Because, I know myself, that might actually be cooler because you could go from chapter to chapter to chapter. But on this one, you just click a link for each run. So I don't know which is better.
But I think the chapter is probably a nicer interface, but the playlist is easier for us to do.
Yeah. So anyway, if you get them, you can take a look at the ones I have up there and add the other ones. I think that if you listen to the first few seconds, at least on most of them, I said something like, "This is Scott's 3rd run," or "This is Raji's 1st run." So you should be able to get them pretty quick. So.
All right.
And David, I apologize for not getting you the address in time. I didn't see my email until I got back from the competition.
Oh, well, I did other things that day.
Yeah.
All right. We had, thanks, Ray and Doug. Next in queue, we had Mike, and then Jesse, then open mic night. So Mike.
Yeah. I'm starting to think about indoor competition and a new motor, a new robot that I'm going to actually take seriously and spend some money on it. Yeah, instead of trying to do El Cheapo. And so the first, I got this camera on order, and I still haven't received it from OpenMV. Supposed to be anytime, and so I'll have that as one of the sensors. But I'm trying to figure out what motor to get. I'm thinking that I need about 1 kilogram per centimeter of torque. So with an 80 millimeter wheel and 4 wheels, it'll have about 1 kilogram of full, of torque for all 4 wheels. I think that's a good combination. At least I don't want to be any lower than that. And if you go a lot higher than that, then the amperage goes up real high. And that makes the drive electronics a lot more expensive. And so I was looking at this particular one. I'm going to try to put it up. See if I can. That's going to pretty mess up a little here.
Yeah, I don't think I've seen any torque ratings on any Chinese motor. Maybe you found some.
So like this one here, seems like a decent one. Like the speed is pretty good. You can move pretty good for indoor competition. When it's loaded, it'll be maybe 100 or 120, which is still pretty fast, like half a meter per second, which is pretty fast for indoor.
Yeah.
For trying to be precise. And then so this is what I was thinking of. I mean, I was also looking on some of the more professional sites, and their motors are about twice as expensive. So I'm thinking maybe I should buy this one and see how it works, and see if it works, if it comes up with to its ideal. So that's one thing I'm working on. How do I get out of here? Stop presenting. Okay. And so I was wondering if anyone had ideas about the motors. Like 12 volts will keep the current down quite a bit. 24 is a little, I'd say, exotic in terms of battery and the power train and supply. And 1 kilogram per centimeter. And yeah, I was wondering if anyone has any strong feelings about that.
Well, I do, but I'll jump in here real quick. Pololu always runs a Black Friday sale, and they generally have their motors 25 to 30% off. Yes, they are more expensive, but I've never had one that wasn't bad. Now there are other motors available, but for a small indoor motor, I think their motors are very nice. Kareem might be able to steer you towards rev motors as an alternative. Rev motors, they're not going to be cheap either, but they're also pretty high quality. So
builders are pretty nice too.
Yeah, so I'm just saying there's plenty of robots, but Pololu's been nice to us in the past, and so I try to support them whenever I can. And that motor you have there, my experience, we tried to build one with 2016. We bought some Chinese motors to try to make an inexpensive club robot, and about half of them worked. I know in my case, I just replaced them. I just bought Pololu motors and replaced them. But we were able to get some of the other ones running. It wasn't so much the motor that was a problem, it was the encoder. And the encoders were not, you're supposed to have a 90 degree offset between your
A and B phase, and it's got to somehow maintain that through all speeds. And what we found with a lot of the Chinese is they were off. And so as the speed would go up, they would hit some point where they just flipped over. They weren't 90. Let's say they were 35% offset. Well, as speed went up, they would get worse and worse and worse, and eventually you'd hit a spot where they didn't quadrature anymore. And so I'm not saying that, like I say, we got about half of them to work well, but some of them didn't. And you're talking about, and I've come the whole journey, Mike. I used to be the cheapest guy in this club. I mean, I made my own wheels. I did everything on the cheap. And frugal, not cheap.
Well, cheap. I pushed the frugal all the way to cheap.
Yeah.
And my experiences, they were good for learning. Okay. But in the end, it was not any cheaper than just buying the good stuff to start with. Now, if you got to remember, I don't use kits, generally speaking. I'm talking components. And
right.
Like after watching, for example, after watching Scott's performance with his robot with those bailiwick lidars that look like this, I now have those bailiwick lidars because I'm going to use them too. I mean, if you look at those run videos when they get posted, his runs, his obstacle avoidance worked really nice, and all he had was 3 of those sensors.
Right.
You know, and I don't think it was optimized, but I do think it worked well. You know, I mean, I wouldn't necessarily agree with how his placement went, but he really did well with it. I mean, I saw him go into the weeds and come out, you know, many times. And at his first run, which we didn't video, he steered off the normal path to this. You know, you have a straight shot to the first cone. Well, you know, Scott, to make it harder, he went off into the woods, and you know, I thought, well, that's the end of that. Well, he hit it, is backed up, turned around, hit it, backed up, turned around until he got around it, and then went straight to the cone. So so you know, there's a case where, you know, I've had one of the earlier sensors from Bailiwick, and I would say it works pretty good, probably 85% of the time. You know what I mean? So I'm hoping these. Otherwise, mine was a TF Mini, and this is now up to a TF Mini plus something or other. So and they've gone through a couple of generations. So I'm hoping that'll help. But there are some good robot sensor deals on Amazon Black Friday this going on right now. You know, all you have to do is up there, you know, where it says categories, it usually says all. You just click on that, select Black Friday, then type what you want to look for. So in this case, I just searched for LiDAR, and you know, there was a bunch of interesting things, more inexpensive ones that would be useful in the indoors. There's, you know, a whole lot of nice stuff. So working those Black Friday sales they generally 25% off. So that's pretty good. Something to think about. And like I say, Pololu, they'll be around 25 to 30% off. And
yeah, that's a good time.
Motors are pretty good.
Yeah, so it's a good time.
I kind of have some rules of thumb, like for the indoor contest, and at least this rule of thumb kind of came about from using motors that rotated at slower rates. Like you can always run a higher speed motor slower if you need to, but you can't, you know, go over whatever, you know, speed rating it has at whatever voltage rating it's rated for. Yeah, you can maybe double the voltage and, you know, pump some power through that motor, but yeah.
Right.
So I don't know. I would say it kind of also depends on the size wheel that you're going to use. Like, it seems like the biggest, the most, as far as wheel sizes go that I have, it's the 100 millimeter. It's like a 4-inch diameter wheel, and they're the skate wheels, or the larger, maybe 90 millimeter Pololu wheels, which are a little. They're not as strong as the skate wheels are because the skate wheels are solid.
Right. Yeah. So one thing I'm thinking. Yeah. One thing I'm thinking about is if you're using odometry, you don't want the wheels to slip, so you want them a little cushy.
Yeah, these are pretty grippy, even though they kind of come to a point, kind of a rounded point. But they're polyurethane, I think, and they grip fairly well. Now, if there's dust and dirt on the makerspace floor, you're probably going to get some slippage. So I don't know. So that's kind of my rule of thumb. I think I've never really thought about the torque. You know, it's kind of hard to say what that should be.
I posted
I think
I posted a typical motor sizing tool link on the chat a few minutes ago, and I noticed there are quite a few of them available if you search for something like small robot motor calculator. I posted one that looks quite straightforward to use. It might be worth having a look at.
yeah.
Okay,
Yeah.
great.
That's a good thing, John. I will say this though: if you Polo motors, you get all the specs, all the curves, everything, and they will also tell you where you don't want to exceed, because you can easily get a motor gearbox combination that is dangerous. Otherwise, you can literally strip out the gears, and they'll always tell you what the maximum torque you should get out of it. And I've never had another problem with some motors that I've seen, though not with Pololu and not with Rev, is if you stall some motors, they will self-destruct quickly. They're not meant to be stalled. But I've stalled Pololu motors without any problem, and I've overvoltaged them because, you know, like Ray said, sometimes you need a little bit. And anyway, just something to, so I mean, definitely look at the Pololu motor specs. They're going to be on sale this week. And I think the calculators that Tom said are, you know, they're, if nothing else, they'll help you work your way through the calculations to find, you know, the inertia you're going to overcome with the size wheel and the weight wheels and how the weight of your robot. You know, most of us use the fail fast, fail quick technique. Otherwise, you put the motor on, and if it's insufficient, then you just replace the motor.
You mean like SpaceX and their rocket ships?
Yeah.
Well, hey, there's a lot to be said for that, especially because, you know, it depends on. Yeah, and you also want to look at. And I mean, like I say, if you have a quality motor, even if you don't use it on that robot, or you'll use it on some other robot.
Right.
You know?
Yeah. Yes, a keeper, basically. Yeah.
Doug, is that the fail fast or the fail fast and fail often theory?
Yeah. That was my robot this year that I made.
Yeah, especially for drivetrains.
Motors, it seems like they max out maybe in the 7 amp range, like for the 34 or 37 millimeter ones.
Well, those are pretty hefty.
Yeah, those are hefty.
Yeah.
Those are hefty. I don't like the motors that I particularly like are the 25 millimeter motors for indoor robots. I don't like the 20s. I like the 25s.
Right.
But, you know.
Mm-hmm. Yeah, because
Yeah.
I'm thinking that I really want to get the geared ratio down to the rotation speed, close to the rotation speed I want to work at. Because it's what it's designed for, but also it gives you the optimum or the maximum odometry.
Well, your max power curve is going to say that your motor has max power at about half speed.
Right, half the no load speed. Yeah.
Yeah, right. Yeah, and then the other thing is you need to have headroom. Otherwise, if you're using a PID or anything like that, you don't want to have your motor running at 95% normal. That's not right. I mean, you probably want to, like I say, you probably want to set your where it would be running at 50 to 60%. Okay, and just when you hit an impact or need that extra power, you can still. Well, you're not going to get any extra power, but you're going to get extra speed maybe. So.
Because I'm thinking that a meter per second is really fast for indoors.
Oh yeah.
Yeah. I was thinking
you got to remember you got
a meter and ran lower than that. Yeah.
Mhm. Yeah, and the other thing too is if you're at a meter per second, you got to slow it down if you're trying to catch something.
Right.
Like in can like 6 can, you know, there's not
Yeah,
enough distance for you to get up to a meter per second, probably.
Maybe we need a new contest like jousting.
David, David Anderson.
Yo, it's called BattleBots. You know what I'm saying?
David Anderson's criteria is you should not have a robot that will run faster than you can run after it.
Yeah,
Good. That's good. I like that, especially outdoors. Yeah.
yeah.
I would. Speaking of that, remind me that we do have a BattleBots competition close to us in December. I scrolled away, but go ahead and finish. And when it's open on the mic, I'll find the link.
All right.
Okay.
Yeah, because another thing I was thinking for the robot body is I saw some videos and some information about some teams are making their robots out of fiber tube and like 15 millimeter or so fiber tube, and then you could 3D print all the ways to, hook all the tubes together, like the corners and stuff. So I'm thinking I'm gonna try that. It'll keep it relatively low weight and really strong, and give me a lot of options.
We used to have a guy who would come down every year from Shybots to run in our line following. And he had a robot about this, I guess 8 by 8, 6 to 8 inches on the side. But, he used everything to keep the weight down so he had low inertia so that he could turn quickly. And, it did give him some advantages. Now, if you're trying to be in can soccer, being a light robot is not necessarily an advantage.
Could add some lead to it, some lead bricks.
Yeah, well, no, I'm just saying, it's not because you're not supposed to be able to hit people, and that's true. But if you hit somebody and he doesn't want, let's say you're a little lightweight and you just kind of let it splat against his windshield, and he's still on track, or he's got a robust way of regaining his waypoint, he doesn't have to call for a stop and reset. He can just let you just sit there on the windshield while he goes off and scores. So, I'm just saying that's something to think about.
Yeah, I could do what Ray did and just put extra batteries on it.
there you go.
Wait.
Yeah.
So,
Yeah.
Double the voltage.
so Mike,
A little on our esoteric side. What is ROS, Robot Operating System? It sounds a bit complicated, but maybe since I'm a newbie, I don't really have any base to worry about that I'm trying to keep.
So you want me to take that one?
That's a good option.
Yeah.
You want me to take
Go
that
for it,
one?
Harold.
Okay.
Yeah, go for it.
ROS, robot operating system. It is not an operating system for robots. It's a system
Right.
for operating robots. Okay, and it's imagine all the the object-oriented engineering approaches. So if you think about it, a servo is a servo is a servo, right? And so is a motor's a motor's a motor. You tell them to go forward or backwards or that at a certain degree. And as a node on there, which is what we call them, a node will be able to say, hey, servo, go this far. And something out there on their network says, oh, I'm listening to servo commands. I will pick up the servo. It tells me to run this way. Okay, I've been configured to know how to talk to the one motor that I know how to talk to, or multiple motors, it could be. But I have the configuration. I know how to talk to the hardware. I will implement this command for them. So basically, it's object orienting and message passing between nodes to make your robot work. And it's really, there's some complicated to it. But if you think about it, a joystick's a joystick, even though we all know they're all a little different. But if I publish a joystick, they call them teleop for teleoperation nodes. If I have a random joystick that I picked off the shelf that I configure that node to understand how that joystick works with all the commands and everything, and I put out teleoperation information, any other thing that's on my robot that knows how to read a teleoperation message can read that and act upon it. I don't need to go code all that stuff to combine them all together. In fact, ROS 2, how it works is that the first node comes up and goes, "Hello, I'm a node and I don't see anybody else on my network, so I will initiate the network, and I will put out. I take these things and I send these things out on my message bus topics, if you will. If you're a message bus service, message service kind of object oriented kind of microservice sort of thing, a person out there in the coding, and when the next one comes online, it'll do the same thing except it goes, oh, there's already a thing there. So I'm just going to add my stuff to it. And before you get it all said and done, you'll have a list of topics and queues for sending messages back and forth. It's more than just sending messages. There's ways to get feedback and that kind of thing. But it takes a little bit to set up. And I was looking at that thing that, who put that out there? Was that you, Doug?
Yeah.
Yeah. I thought it was good. I spent, like I say, 37 seconds looking at it. And but the idea gets it started. Now I really want to see the next time about how he's implementing all that stuff on the ESP32.
Yeah, I was looking at that too, and I think that might be that if he really writes all of the whole thing instead of just part one, then that could be an easy way in.
I think it'd be really good. In fact, just so that you know,
put an article out on the list.
Just so that you know, the Roombas. In fact, the Roomba Create V3 that you can buy off of Adafruit right now is a ROS node that you can talk to do all things Roomba. Not all things Roomba, but there's a good selection of things you can do. And it's got the implication with this is it's just not. It's a standard. So it's not us building a robot to do the thing and following some standards. No, this is a standard. Like, for instance, all the Amazon robots that are running around their warehouse doing their things, they've modified it because it is open source. It's all running ROS. It's all ROS based. The iRobots are all ROS based to do what they need to do. Because the idea is every time I build a robot, if I've got to set and rewrite the same motor control code that I've written 27,000 times because now my library, I lost it and I got to go copy it over. Instead of that, I've got a motor control node and I've got some XAML configuration that says, you respond to these types of messages and you respond this way. And in fact, that's what I did on my rover over here. I've got two different types of servos. I've got steering servos and driving servos. So they're continuous, and the 180 degree ones, and they've got some that are continuous. And every node knows whether it's a continuous thing or a 180 degree. So when it gets drive commands and that kind of thing, that node will translate those into something that's useful to the servo that's driving it, and the node knows. And the whole thing with doing the navigation guy, he says, hey, servo 1, I want you to do this. Servo 2, I want you to do this. And servo 4, I want you to do this. And then those individual things will now know enough about themselves to do what has been asked for them, or actually do nothing because you sent me a command I can't do. That sort of thing. The intelligence is broken up in little pieces. Did that help?
Yeah, and there's another thing to it too that's potentially useful, but also potentially dangerous. Because ROS is pretty much across academia and industry, you get a certain amount of boost on hard problems. Otherwise, like SLAM routines using LiDARs, they're all written and they're grafting and troubleshooting and all of that's already done.
Or Viv,
and you don't even have to know anything hardly. Well, the more you know, the better off you are, obviously. But though somebody else has written that and you haven't written them. And so you get a big boost on the different packages that are available to us. The downside is you don't know anything about what's inside of them unless you do some study. And if you did it and it didn't work, you're sometimes lost on why. Okay, because you didn't put in, you don't know how it was constructed. And because they're coming from all sorts of sources, though from what I've heard from people who are more familiar with it than I am, in general, the packages are very, very well written.
Mm-hmm. And they're small and hopefully easy to understand if you have to go break them open and look at them, hopefully. Everything is Python or C++. So,
Yeah, because like an autonomous robot would using ROS would have it seems like it's optimized for a Raspberry Pi as the brain, and then all the sensors are nodes with some kind of a serial interface. And,
that's a real common configuration.
Very common.
Common
so I was
configuration.
thinking of using the Pi Pico as the node, as the like the wheels. I would have the motor controller and the encoders going to the Raspberry Pi, and it would have a high-level command in it. It would close the loop at the Raspberry Pi. And
Well, look at that guy's that article that I sent out. And Ray, did you find it in your email?
I haven't looked, but I'll look.
The reason why I say it is if
I
you
looked over it pretty quick. And I saw it. It seems like a decent thing. It seems like this is a good deal. I really want to see a software, how he's loading it to actually make a determination. Is this something to pass for everybody to go down? Because if it is, it looks so far. Hey, go get this stuff. It's not a whole lot. Doesn't cost a whole lot of stuff, and maybe you get started. And on my stream, if this is a great thing, because if this is on my, if it's done well, I'm going to copy this and we're going to build it on my stream and see how it goes.
Mike, you probably have most of the parts already for that article. Because you had like I say, he claims that, I think he said $60. It would be $60 or less. And in his case, he had several of the parts. And for anybody who's already got some sort of basic chassis, probably be less than that. I mean, you don't have to do the motor drivers and everything. You already got them. He's just using the most inexpensive, most common components.
Yeah, he's got his 298 in there and all the other things doing. He's like, I'm like, okay, cool.
Yeah. Now, in his case, he hasn't really mentioned what he's going to have as his ROS controller, and I got a feeling it's probably going to be a laptop.
Yeah, that's what I'm guessing too. I bet he puts micro ROS on the ESP32 to make it sort of a node respondent sort of thing, and then using a laptop to then send that out, because that is another cool thing that can happen because the way it's set up. If you want, for instance, I can code on my laptop and it's all UDP protocol that everything is talking. So it ended up working when I tried it a few times. Just right out, it says do this and then do that. I'm like, wow, okay. I'm debugging on my laptop, and the robots running around on the room because we're on the same Wi-Fi network, and they're blowing UDP everywhere. And it made it real nice to consume those messages, or in my case, inject messages and watch the robot respond expectedly or unexpectedly, whichever way I didn't want it to respond. That kind of thing.
So, I mean, it's definitely something. If anybody doesn't know what we're talking about and they've checked their email, then there's possibility that they've gotten dropped from the list. If they're dropped from the list, please let me know and I'll put you back in. The list will drop you if for some reason it doesn't like you after so many times. and I don't know what initiates not being liked. So,
Well, then
You know,
Ray's still on the list, so it can't be too bad. I'm just saying.
yeah.
I had to pick it, Ray, man. I just was waiting for
So Harold,
do it this weekend, but okay.
I understand that, like on Ross, you can, like, a preferred way to do it is like use a laptop as a development platform to your robot, and then you can basically download or convert or whatever into the Pi that runs autonomously on the robot.
Yeah. And in fact, if you go look, there's maybe a Docker image that has a ROS installation and everything for you all ready to go if you get a big enough Pi. That's what I'm running on my rover is Docker images to control it and fire it up.
And then a Micro Ross, they seem to have a version and tools to get it onto the Pi Pico. So
That's going to be a challenge. I've never successfully gotten Micro ROS actually to do anything, but then when I was trying, it's been a while since I've tried it, and when I was trying it, I was learning a bunch of other stuff at the same time, so I might have shot myself in whatever pinky toe or something, so it wasn't ever going to work.
Hey, Doug, can you put a link to that article in the Slack?
Yeah, now I don't know if everybody can get to it. It's median, and median sometimes.
Or medium.
Sometimes it's a little weird.
Yeah, no offense. I almost didn't click on it because I saw that medium thing in the header of the thing,
But I think this is from his particular website. So usually you get like 10 freebies or something like that with them. So anyway, you might, if you get it and you like it, you might want to copy it, turn it into a PDF. I'll put the link in, Carl.
Okay.
All right. So basically, I'm just going to try to do a little more, quote, professionally this time, instead of putting parts together and making dirty code and trying to make it work. So,
hey, you mentioned wheels, and we didn't talk about that much. I just had a question out there because we don't see them much, but like David Anderson used those big fat wheels for model airplanes, and they seemed sturdy and grippy. He had to make hubs for them, but what's the club feedback on those versus like the skateboard wheels and the Pulolu and the other wheels we use? Are they as sticky and decent as they seem to be? Any thoughts around the club?
I've never touched it to find out how sticky it was. No. I don't know. I don't know if they're polyurethane or what they are, what they're made of.
I guess my biggest thing was I didn't actually find them very easy to find. And when the big ones, the little ones are easy to find, but big ones like he was using on his, I found them a little hard to find. I'm sure they're available, but they're probably not any cheaper or anything. They might be a little lighter.
Yeah, because usually those airplane wheels, they're not really meant to be motorized because you're just rolling around and they're just on a bearing or whatever, right?
Unpowered. So I know when he's used them, he's done nice aluminum hub machining and such. But okay, well, basically no feedback. I just wanted to, Mike, as you're noodling through options.
I will say this on the things that Ray showed, the scooter wheels, or those, Polo makes some wonderful hubs for them. They just, I think they're $5 a pair, and you just pop them on there, and you don't have to worry about fitting it onto a shaft.
Or slippage. Yeah, they're pretty good if you tighten them up.
Yeah.
Yeah.
All right. Well, thank you.
They aren't the lightest. There's, some, I don't know how much it weighs, maybe 8 ounces or so for the 100 millimeter one, but
they're durable.
Yeah. Yep.
Okay, I'll put that link up there. if you haven't seen it, you might want to look at it.
Cool.
Yeah, Pululu's sale, I just saw an email that it started, so
Oh,
you
really?
may even get them for cheaper.
I don't know.
Don't know if the pubs are
Yeah.
for sale.
Usually, I think they go on. Oh, I don't know. The wheels go on sale quite a bit.
Mm.
Yeah, and they also have scooter wheels. So if you're making an order, sometimes if you throw in a couple of scooter wheels, you might end up over their next price break.
Or free shipping.
Yeah.
Well, I don't know. Does Pululu have free shipping? I thought they did.
Yeah, but I think it's like $100.
Oh,
I'm not saying that I haven't spent $100 at Hulu, but probably not.
one robot unit, $100.
Oh, Go Build is 25% off for this week. That's another definitely for structural steel. That'd be really good thing.
Looks like I got some research to do tomorrow. Yeah.
Oh yeah,
Their stuff's
Like I
aluminum primarily.
yeah. Like I say, don't forget Amazon Black Friday sale, because I was surprised at some of the things that I found there. Otherwise, once you put it on the Black Friday category, then you just use normal search terms. So anything you want to look at, you can find. So it's kind of cool. You don't have to go through 5,000 dishwares and aprons and stuff to find one thing that might be useful.
Doug, what was that LiDAR that you were holding up a minute ago? That was TF Mini?
If you look at the robot interview for Scott's Belch robot, okay, BELCH robot, you'll see on top he has 3 Bennywick LiDARs. One's pointing forward and the other ones look like they're pointing 20 degrees or 15 degrees.
Yeah.
Huh?
Those were Benewaki LiDARs?
Yeah, they're these are normally, I want to say they're just under $50, but right now I picked these up for $42.
Yeah.
And then I cursed myself because I saw one for $39, and I
Amazon's got one for 26 right now.
Oh, those are not the same ones.
Okay.
Those are the ones that we're using on outdoors were called the TF Mini. Keep going down. I think that you'll probably go. There it is. There's the $42 one. That's the one I got right there.
Okay.
The top one.
Right.
Okay, now for indoor robots, you should, that one's a 12 meter. It uses a UART. Supposedly, you can switch it over to I2C if you configure it through the UART. Okay? Otherwise, you have to go into the UART and set some registers, and then it's an I2C. Though I don't plan to do that. I'm planning to make these 3. I'm going to use I think I'm going to just put a Teensy 4, which has six UARTs on it, and I'm just going to make these 3. They make this sensor array. I'll probably add some other sensors to it too, but I'll make the array be just a sensor array that talks to one microprocessor, which then talks to the main, right? Just passes information.
Okay.
Yeah, and ROS, you put the ROS controller in the Teensy or whatever, and then you have a ROS interface. I can't remember what it's called, but
Yeah.
it's like a defined interface.
Well, I will say I because I don't tend to use Wi-Fi in my robots.
It's not Wi-Fi.
No.
Yeah.
No, but I'm just saying, since I don't, I tend to not look at ESP32s.
Oh.
And I'm not, there's so many versions of ESP32s. I'm sort of in microprocessor lockup. Otherwise, I keep saying, well, I want to explore these guys, do I get a Zoom R172 or a D647-9 or a, and they all sound like they're cool. And then you you go to different forums and they say, well, you don't want that one, boy. You get that one, you just blew your money for nothing. So I finally found one that I thought was cool, and I went to the Expressive site, and they said don't use for new designs. So I'm going like, I don't know what I'm going to do with that, but someday I'm going to explore that.
There's probably a million of that one out there anyway, so
Yeah, it's a very powerful. Yeah, it's very powerful. So it would be a very good processor to learn nowadays.
I'm using
And it has Wi-Fi and Bluetooth. And the Bluetooth, even if you didn't use the Wi-Fi, you could use the Bluetooth to do your tele-op.
I'm using ESP32H, I think, and because I have a Wi-Fi project, and it's working well. I think I pushed its CPU power though. I put too much crap on it, but yeah. Okay, I'm done again. Yeah.
Okay.
Cool. That was a rich spark of discussion. Nice catalyst there. So next in line, if you're still there, we have Jesse, and then Harold has a BattleBot reminder, and then open mic.
Yeah, I'm still here.
Cool.
I have a slideshow for you. Let me get it started here.
Slideshow. Ooh.
Wow.
It's over the top, Jesse.
I know.
Well, I actually have enough. I could do a full 1 hour presentation, but I just have a
Raising the
summary for today on what I'm working on. Then I have I have a couple of classified pictures I'd show you at the end, but we'd have to do it after the video's turned off. So because they're of my competition vehicle, so sure. I don't want to give any of my competitors any secrets.
That's cool.
I want to open the kimono too far.
All right, see my slide.
Open the kimono. Okay.
You see it?
No.
J Rover Racer.
Okay.
Oh, why am I not seeing it? Huh.
I'm sharing. I'm set to presentator, so
it's working now. Thanks. Yep.
Okay. So it's kind of ironic you guys are just talking about ROS because that's actually what I'm using for my rover. I'm building an F-110 RC car, which is designed for a competition. This competition is between universities and individuals like me who want to race. I don't have a lot on F-110 right now, and that's why I say I could do a whole hour presentation on what F-110 is and what I'm doing. But here, actually, you can see kind of the diagram of my rover. My input on ROS is it's very complicated. It's hard to understand. To get started, it's quite a uphill battle to get going. And my discussions with one of my friends who actually does this for a career is that people tend to get carried away with ROS nodes. They have a ROS node for everything. You have a ROS node to read one servo, you have a ROS node to read another, send information to another servo. Where if you look here, what I'm going to do is have what I call rover mind. And rover mind will actually have input from the LiDAR directly. I'm not going to be using a ROS node for that. So the LiDAR input will go directly into the mind. And then to the right, we have rover control, which is a separate ROS node or thread, which will then communicate with the Teensy. And then here you can see the Teensy will have a BNO 55, a steering servo, a speed controller, a kill switch button, one regular encoder, and then a PPM receiver for my radio. So the radio would be like manual commands or panic, turn off, shut off, whatever, something like that. And then I have an encoder too, and it's kind of funny because you guys were talking about brushless motors and using the encoder channels, and that's what this actually is here. It says IO ×2, and it's actually supposed to be ×3. But I have it set up to actually read the pulses directly from a Castle brushless motor that has sensors built into it, so I can get the direct feedback from the motor instead of using a standard Hall effect encoder on the drive line. I can actually have the Hall effect sensor directly in the motor, so that eliminates some points of failures and also gives me a higher resolution signal.
So Jesse, on that, are you using a motor that, quote, is sensed? You know, you get the motors, you can buy motors that have the sensors built in.
Yes, correct.
Or you can buy a sensor module that hooks onto the lead.
I'm using a pre-existing motor that has sensors built in. What I did is I built a little breakout board that goes between the motor and the ESC, and it intercepts the signals from the Hall effect sensors and then actually sends it on to the ESC. I'm doing that so I get better low speed performance, because brushless motors, when you give them the sensors, they can run at a much slower speed, much more accurately and much more efficiently. If you don't have the encoders at low speed, you're going to get like jerkiness and other weird low speed startup behaviors. So by using the sensors, I can get better behavior at low speed. So my rover will be able to go much slower than most of the other ones in the competition, because most of them are not using sensor feedback, or maybe they are, I'm not sure. But we're specifically supposed to use a special gear ratio, so I can't just use whatever gear ratio I want. They want to try and make the competition as similar as possible, so they say use this gear ratio. I could probably get away with a lower gear ratio. It's also ironic you guys are talking about 1 meter per second, whereas in Formula 1/10 it's indoor and we're talking as upwards of 8 to 10 meters per second. So that's 20 to 22 miles an hour for those keeping along. So I have my rover mind, which is going to do all the primary decisions, and I'll show you more details on that. But I have rover command, which is basically a little terminal-based UI, which shows the status of the rover, and you can control it here as far as what mode it's in, maximum speed, and other parameters. It's text-based, so that it's just using a SSH shell, so it's very lightweight. No images or anything like that are being sent during the run. So it's just a couple bytes per second is all you really need. And you can even get it so it doesn't display anything. So it's just there to start the rover and stop it and see a little data if you want. Then RViz, which is a visualization tool for ROS, where you can send in maps, or you can send in coordinates, or you can send any type of data you want. And RViz will then show you how to visualize it. That's something else that I don't have a lot of documentation here, because this presentation is actually for a group that knows all about that. Over here to the right of ROS, we have this module called Sim, and what Sim is basically a 2D simulator that I wrote that basically emulates the vehicle, and then it can send data to the ROS node. So if you want to test your code in ROS, or you want to do a standalone simulator, you can hook up rover mind directly to the sim and just control it that way. The sim is also able to generate LiDAR data. So the rover mind, instead of getting it from a real LiDAR can get the data directly from the simulation. So then in the middle, we have the ROS node. Then below that, to the left, we have nav2, and nav2 is basically code designed for ROS, which allows you to either do SLAM or do AMCL, which is basically using a SLAM-generated map to locate where you're at in the world. Then it also has a map server, which either AMCL or SLAM generates the map, and since it's a map server, then AMCL uses that map from the map server. Then from the map server, you can save that to a file, and then I can run a path optimizer on that file, and then generate a path, and then that path goes into either the rover mind or the sim or both. depending on what you're doing with it. So in the sim, you can visualize the path, and then the mind actually uses the path to generate steering and throttle commands.
Cool.
So this is like the fourth iteration of this. My previous iterations had a lot much more involvement of ROS and other things, and I've run into issues with delays with communication. So like if I'm doing like a peer pursuit controller, I get oscillations due to the delays of sending the position data to the controller deciding what to do, and then sending that data back to the node, which is then going to use that data. So there's delays there, and any delay will of course lead to issues with your control system. So delay is kind of the enemy of any good control system. So the less delay you can have, the better. So this is actually the back side of the board I'm actually using on the rover. I couldn't find a good picture in the 5 minutes I was looking for here but in essence, it's a teensy 4.0 breakout board that has inputs for the servos and I2C and other channels, and SPI as well. So you can, in essence, plug this directly into a teensy and use it on a rover. I can get some other pictures of that if I give a bigger presentation. But I designed it myself in KiCad or KiCad, however you want to pronounce it. So here is my actual simulation UI. In essence, here you have a map file, which is in essence a YAML file, a markup file, which tells you the dimensions of the course and like the offsets and what each pixel represents as far as resolution. So the white represents the area which you can navigate, black represents walls, and gray here indicates that it's an unknown area. So in here, you can just click solve and it'll simulate the vehicle. And I have map files, and I have a raceline file which tells the optimal path. So that path file is what the raceline file is here. So here you can see simulated LiDAR output. And so I'm taking all the LiDAR signals and recreating a map. Or what I call a local map, so that I can see where the rover is headed. So the green line is where the rover is going, the path it wants to drive, and the yellow here represents where the rover will be in 1 second. So that way you know exactly where the rover is traveling. And then here you can see from the UI when it's running, you can kind of see the path that it's showing you. The green below it, this thin line is the desired path, and then the thick green is the actual path traveled. The purple on the lower right is what I use for lap detection. So it has to be on the inside of those two outer lines, and then it's got to be on one side of that line for the start of the lap, and then it's got to be on the other side of that line and cross over it to detect a lap. So my code can actually detect laps and timing for laps. It also keeps statistics on distance traveled, average speed, maximum speed, etc. So I can get all the statistics I need on the lap data. Then here you can see on the left, you can see what the LiDAR sees. So here you can see the red dot indicates that it realizes the path is blocked. And so it's just under a second till when it's going to impact, because the red is closer to the vehicle than the yellow. So the yellow is 1 second, so that's like 0.9 seconds or something. So that means it knows it needs to make a correction. If you look on the right, this is actually the map that the planner actually sees, though, because I'm using two maps here. I'm using one map, which is the course as it was found by SLAM, and then the map on the left is a separate map which has the obstacles in it. So the LiDAR will see the image on the left, whereas the map server, etc., would see the image on the right. So that way it's realistic to the case where you have an obstacle that was added to the course afterwards, like a box or another rover, etc. So here's what I have working so far in my controls, the control algorithms. I have a wall following algorithm, an algorithm called disparity extender, which looks for open gaps away from the current location as far as possible, and it tries to shoot for that gap. And it's very good at what it does. It's a bit limited, but it's really surprisingly efficient. Then I have another one that just looks for a gap at least 2 meters away from the vehicle, looks for the biggest gap and heads towards it. Then I have 2 different peer pursuit algorithms. One is one I've used for years with Spark Fun, ABC competitions, etc. And number 2 is a algorithm I found in Python, which is used with the lap optimization code. So it's designed to give you ideal parameters for that peer pursuit. So it gives you exact turning at each point in the track. So it gives you what the ideal track path is and steering, and then it only needs to deviate a little bit based off of air. Then I have a Stanley-based controller. It's basically, it uses 2 sources of data for correction, the cross-track air, and I believe it's like the distance away from the path or something like that. So it's just a slightly different controller. And then for path and obstacle avoidance, I have A star algorithm and also RRT star. So they can look at the LiDAR output and then trying to find their way around any obstacles. Then to generate the overall path, I'm using what's called the TOM Global Race Trajectory Optimization. It's basically a group of Python scripts which take a track and determine the ideal path and speed for the entire track. Mm-hmm. So TOM is a university over, I believe it's Munich, and they actually do racing not only in F110, but also with full-size Indy autonomous cars. So if you guys haven't heard, there's actually full-size Indy cars that are racing autonomously now.
Is that Jesse, is that the one that you see where they had cones like all along? There's one that I saw, the small race cars, where they had cones outlining the course, and it was, as it was going along, I mean, right next to each other, so there was a solid wall of cones on both sides of the course, and the car was running through them. Is this the same? Because I believe it was over.
No.
Okay.
Indy is on full-size racetracks like the Indianapolis 500 track, or the track in Vegas, or other tracks like Monza over in Italy.
So they're not. How are they? They're leaving the boundaries just natural.
GPS and high-end LiDAR and stereo cameras.
Okay.
They have much more processing power than you can imagine. They have like 3 to 5 LiDARs, multiple cameras, high-end PCs in them. They're $1 million cars.
Yeah, gotcha.
I actually watched the first Indy autonomous race in Indianapolis, and it was pretty impressive. But all they did is race individually. There was no side by side or anything because of conditions, and the technology is still pretty new. Mm-hmm. So since then, they've done the side by side racing, just like passing only, though. There's not like real competition of multiple cars racing on the track. Mm-hmm. So they have a long ways to go. So I have currently 2 different levels of simulation for my physics. I have a simple bicycle model with a speed versus turn angle. So the faster you're going, the less you can turn. So you just have a maximum turn minus maximum turn times speed times some factor. So it's a very simple algorithm so that as you go faster, you can turn less. Then for the medium resolution code, I actually have a code which was from the F110 simulator. So it's actually a Python-based simulator that's designed to work with or without ROS. So you can actually create your vehicle there and test it. So I took that code that was in Python and converted it to C++. And it has like 7 states. So it takes into account like drift and stuff like that, so you can have a more high fidelity model of your vehicle. It's like a arcade based integrator. It's nothing fancy. And then I'm looking at a higher fidelity simulation and something called Project Chrono, which is a C++ multi-body simulation software package. And there I should be able to really fine tune the parameters of the tires and the vehicle to get very close to the physical behavior of the real car, if that's needed. If you want to do an AI and really push the limits of the vehicle to the absolute nth degree and get the last little bit of traction out of it and get it to handle situations where you have a slick surface, etc., then you really need a very high fidelity vehicle model. And it really comes down to the interaction between the tire and the surface and modeling those interactions. So I don't have pictures of my car here because I'm doing some new things and I'm not willing to share those details with my competitors yet. So this is the part where I say I'd have to do it after the video is over. But in essence, here you can see what the cars look like. They're slash vehicles with a LiDAR on the front and then some type of computing module. These are Jetson Xavier AGXs, I believe. And then on the back, we have this big wing, which is there to act as a LiDAR reflector so the vehicles behind you can see you. So these cars, the LiDAR is 1600, the Xavier at this time was probably 1500, and the car body and battery and all the other electronics. So these cars are $3,000 to $3,500 a piece.
Mm-hmm.
It's not your garden variety garage racers, so they're rather expensive. And FYI, I have two of them.
Whoa! So you have two of those
Yeah.
LiDARs?
Yes. And I have two Xaviers. I have two cars. I have two batteries. I have two power converters, everything.
Yeah.
And then,
Did you see the article that was in the email list about the NVIDIA contest?
yeah, that was me. I sent that one out.
Okay.
It's first place is $13,000 worth of prizes, which includes or an AGX and a high-end laptop and a bunch of other things. So it's a pretty insane contest. There's three categories. The generative AI. There's two categories. The first one is like generating your own generative AI, and then the other one is using a generative AI for your project. And then the third one is like open to robotics, and I have a feeling that one is going to be much more contested.
They're giving away 10 of those orange,
Yep.
So have an idea, submit it. I've done a lot. By the way, I'm a Hackster IO ambassador, by the way.
Nice.
For FW. We haven't been doing much ambassadoring for the last 3 or 4 years, though, but I am one of those things.
Yeah, and I'm a SparkFun brand ambassador. So.
Oh, that's fantastic. But I've won several of those hardware packages.
Mm-hmm.
Sometimes they'll say, if we give you hardware, we expect you to do a thing, or we want the hardware back. And I've seen that a couple times, but normally once they give the hardware to you, it's just given to you. Right. So, and I think it's cool.
Yeah. 2 years ago, I did a competition with my Lego Rover, and they gave me $200 to buy Legos and also Luxonis cameras to use. So I had a Luxonis camera, and Ted got a Luxonis camera too, and $200 for Legos.
Yeah. I went and looked up those orange are they're clocking in about $500 a pop.
Yeah. So, that's what the Nano development kit runs. And if you win, an Orin AGX is much more than that. They're like $1,500 to $2,000. So if you win, it's
so go submit.
Yeah,
you never know.
Right, exactly. So I would suggest if you want to do the competition, look at the generative AI, unless you just happen to have an amazing robotics solution. And the only requirement there is that you have to use the Jetson software SDK. So you can in fact use any different Jetson board, whether it be an older Nano or Xavier or Orin or whatever you want to run. So I don't have any slides on it, but my future steps are to take the simulation, get it polished, and then actually start running on the Astro rovers. So the rovers are built, they look kind of like the image you see here, but I've taken some steps to streamline the design, and that's where the secrets are, and that how I've done it and the amount of time I spent doing it. I don't want anyone to just be able to replicate it easily.
Yeah.
So if you look here, you can see the LiDAR on the front. You can see the Xavier right behind that. Behind that is a VESC speed controller. Most of these rovers use VESCs for some reason. I'm not quite sure why. They think they give them better feedback for encoding because they look at the motor counts for the pulses to the brushless motor to get encoder feedback, but I'm not convinced of that, and the extra weight of the VESC and the complexity to me isn't worth it. And then on the very back, you can see the two Wi-Fi antennas for the radio. I have my own solution for all of this. I'm not using really any of the code that they provide, but the Formula 110th is actually a class you can take, and they have like 10 lessons that start all the way from the beginning and work your way through ROS, and by the end of it, you're competing. So that documentation on our class is available for free, and they're updating it right now for ROS 2. I'm actually going to provide a presentation or two for them for the class that they're going to be doing here. So competitions are held throughout the world, whether it be US or Europe or even like Asia, like Hong Kong or some places like that, India. Next year there's going to be an event in UAE too. So they're all throughout the world. This year there was actually one in Alaska. There was one in Austin. And then there's another one in Detroit for the US this year. Next year, I don't think there's going to be any competitions in the US. So I may be focused on just getting my rover ready for the competition. But it's a really interesting way to get involved in a competition and be competing against college students. A lot of them are going to be working on their master's or PhD. So you're going to be up against some real competition. Nobody takes it lightly. And my hope is to be able to go in there and at least be competitive. I'm not so foolish to think I can win automatically. I just want to be able to compete and being competitive and say the top 3.
So Jesse, would you say that, are you familiar with Donkey Car? Would you say this is just another level compared to that?
Right. This is like 2 or 3 levels beyond Donkey Car. Donkey and the other things like that are usually mostly line following or maybe some type of what they call cone slam, which uses the cones for navigation. This really is using higher end LiDARs, and the speeds involved are much higher than what you would normally see in a Donkey Car. The other thing is the courses are set up with like a barrier, which is approximately 12 inches tall. So you'll have a good, nice walls for your LiDAR to bounce off of. I question sometimes the material they use for walls because they may use, say, a black pipe material, which doesn't necessarily reflect a lot. I would prefer if they stuck to lighter colors like white, but so your maximum range may be somewhat limited. But I haven't really had enough testing yet. I have different materials from the different tracks they've created to test. And creating a full track can be very expensive because this tubing that they're using is like 12-inch HVACA tubing, and it's like a 20-foot section might cost $50, and a track might be 100 feet long. So I might need 250 or 300 feet of the tubing to make a full-size track. So if you do the math really quickly there, you're talking you're talking hundreds of dollars worth of this flexible tubing to replicate a course. So I'm always looking for ways of, I'll have those tubing for comparison, but then try to come up with a lower cost option for making a track, like insulation board, like fiber board or something like that, to make a lower cost track. And like I said, I could go into all the details about all the subsystems, and I could really break this out into really intricate details if somebody wanted to hear a lot more details. So if you guys want to have like a monthly meeting on it, I'd be happy to present that.
Okay, that's fair.
And I also know everything there is a lot about ROS. I won't say everything. I know a lot about ROS. So any questions you have, I can certainly help. My solution is to use just my own code to communicate with the Teensy, and I'll have a ROS node that just communicates between ROS and the Teensy. Between the ROS and the Teensy will just be standard serial-based communication, just short messages, fixed format, just saying, here's your steering, here's your speed commands, and you see back the encoder data and the IMU data. So to limit the amount of data and the complication of micro ROS, I'm not convinced on that yet. So the IMU works really well. It's the Bino 55 that I've used for all my projects, and basically the rover will be given a heading, so you don't even necessarily have to update the IMU that frequently, because it'll just know what way it's supposed to be headed, so you don't have to send it commands instantly all the time. Just make little adjustments to the steering. It'll be automatic. And I have other secrets, again, I will share later. All right.
Hey, Jesse, there's a question in the chat asking about what is our weight.
It's a standard. Yeah, it's a standard slash. So the cars usually weigh around 4 to 5 pounds, but by the time I get all my electronics on there, I don't know, 8 to 10 pounds is potential. Again, I have some ways of lightening it that I am using to try to get it down, but I actually haven't weighed it lately, so that's a good question. I'll try to weigh it tomorrow.
Let me ask you this. When I've used 10th scale models, I've had issues with the suspension bottoming out. Are you doing anything special to the springs and whatnot, or is there any consideration when you're selecting the particular model of 1/10th scale car?
Yeah, I'm increased my stiffness by adding stiffer springs.
Yeah.
I've added a internal limiter to reduce the actual ride height of the vehicle so it rides closer to the ground, because the Slash is really designed as an off-road vehicle, but it's being used more in an on-road sense here, so I don't need to travel of 2 inches of suspension. I really only need like a quarter or a half inch.
Yeah.
Then you can also add adjustments to the springs by tightening an adjuster there, so you can change the preloading on the springs to get different rates. So between those three things, I have adjustments I can make. I can also, if I need to, I can adjust the weight of the oil in the shocks, but I haven't done that yet. So I need to do a bunch of testing and just adjust for the road height, etc. And I also am not set finally on my design, because I want to look at the center of CG and potentially make some design changes to where my parts are mounted to come up with a more optimal CG and try to get left to right and forward backwards load balance on all my tires, because it's a left and right course, so I have to try to keep neutral balance in the vehicle. So I actually want to get a corner scale weights like you have on a real car and do that with my RC car and get it balanced properly. So I don't know that anyone's ever taken this to that degree yet in this racing. So I want to really make it as accurate as I can, and I have sway bars and everything. So I'm really trying to accurately replicate a full race car as much as I can.
You know, Jesse, I'm glad you just said what you said. Like, no one's ever done this before. I want to do the most accurate thing, and I could do this thing. We do one more. I think a perfect example of thinking we knew everything we could do is the micro mouse competition. Back in the late 70s, no, back in the late 60s, they thought they knew everything they could do to make that mouse go fast, right?
Mm-hmm.
And then somebody figured out that I did not have to square to turn, and I could do like an angle and turn.
Yep.
Figured how to make that, and it blew the world apart, right? And then they knew they couldn't go any faster than that, right? And of course, yeah, you see what they do now, right?
Right. They have the vacuum to hold it for drag, and they have all those tricks. I mean, if you guys never seen micro mice running, they are very impressive and much faster than you would imagine.
Yeah, I'm blown away with what they're able to do with so little code and so little devices, and just make. I'm blown away by that.
Yeah, this is definitely a big boy's micro mouse.
Hey, Jesse, on the B&O 55,
Yeah.
are you running that in full fusion mode?
No. I am running it without the magnetometer because of all the issues with the magnetometer.
Okay.
So I'm using it in NDOF mode, I believe, which is with everything but the magnetometer. The automatic adjustments of the magnetometer make it just inaccurate. Over 5 minutes, over like the ABC link course or 5 minutes of time, I can have a angle error of like 5 degrees without the compass, without the magnetometer.
Okay.
And when I'm running with SLAM, I will now have, or AMCL, I will have corrections from from the LiDAR, so I will have very accurate navigation data over the length of the course race, which could be between upwards of 10 laps. So I need it more accuracy than I can get out of the B&O by itself.
Okay, so have you ever measured how much? Because what I've seen on the B&O when I've tried to use the absolute compass heading, is that it's rock solid when it sits still, but as soon as you move it around, then the compass heading starts, especially if you rotate like in a certain direction clockwise over and over again, it builds up some error from them.
Right. That has to do with the auto adjustments. It's designed to auto calibrate as it's moving.
Yeah.
And those over time, especially with a small rover, you have a very noisy magnetic environment, and it just is not able to handle it. So that's why I just disable the magnetometer completely.
So you've seen the same thing. All right.
Oh yeah. I mean, I've been using the B&O since like 2015 now, and I can do an ABC link course with a less than an error at the end of the race of say 800 feet track of less than a foot or 2 foot.
Yeah.
Just doing dead reckoning. So.
All right. Thanks.
Yeah.
Well, that's pretty cool. Thanks for the update. There was one other question. What's the length of these cars?
They are like 22 inches long. They're
almost 2 feet. Okay.
Yeah.
Good size.
And then they're around wheelbase is 0.3 meters. Sorry, I get my terms mixed between meters and metric and inches, but the number I keep seeing for wheelbase is 0.325 meters.
All right.
And then it's like 11 inches wide, 12 inches wide. So it's just your typical 1/10 scale.
Pretty cool.
Thank you.
Carl?
Yes, sir.
Why don't we, unless there's somebody who has another topic, why don't we stop the recording and let Jesse go on with this portion? And if there's more, we can return to a recording and make a second recording.
I have something I want to show, but I don't know if you want to wait until the second recording or now.
Well, okay, so we'll add you after Harold. So I don't think I can pause it, but I can definitely stop it and restart it.
I have a brief thing too, real brief.
Yeah, I don't see a way to. Unfortunately, they don't let you pause and restart, from what I can tell.
And let's do it afterwards. I can wait.
Okay. Then we had Harold, and then John, and then who else spoke up? Doug. John K. Doug. D, and then we'll go back to Jesse off the books. Okay.
All right. I got to post something into the chat so you folks can follow along on the home game. And then we'll switch over to, oh, not that one. Here, let me pull this into view. Da, 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 da. That's what I've been doing. People have been talking, modeling up my make plot robot thing. So these people here, Texas Robotics, Robot Combat, will be holding a robotics battle on December 9th at Rev Robotics up in, I believe it's Denton. So these
No, that's in Carrollton.
Carrollton. Sorry, got it wrong. Carrollton. I can't read. Reading is fundamental, and I missed that class. So it's going to be in Carrollton. This is the entirety of the information that I know. The robots start gathering at 9:30. Fights start at noon, and this is all ant weight competition, which I was just looking at what ant weight meant, and ant weight means 150 grams or less. So you may ask yourself, how much damage could a 150 gram robot do, and how exciting is they are to watch? Well, I'm friends with one of the people that helps run the Las Vegas Makerspace, and they also do a bunch of the 1 pound, 3 pound, and ant weight robotics competitions. He runs around and videos them, puts them on the air, that kind of stuff. He's got some videos out there. Some of these little things are vicious. I mean, they're just absolutely vicious as they go at each other. So I'm hoping. I've got a lot of things going on in my life personally, so I don't know if I can make it on Saturday, but I hope to go show up and watch some ant weights beat the stuffing out of each other. And some of them are plastic, some of them are metal, some of them are whatever. There's got a whole series of rules there. If you click around on the link, you'll find the rules and things to it. And oh, look at that! Somebody had one of those muscular doll arms to beat somebody else with.
Those are actually 1 pound.
Those are robots. Okay.
Yeah. Ants can be between 150 grams up to 1 pound.
Up to 1
depending on the terminology.
Okay. Keep me honest, Jesse. And so I'm showing you the breadth of my knowledge, the depth of my knowledge right now with whatever's on this page. So it looks like it's a lot of fun, and I've seen some battles on the video that's a lot of fun, and it's going to be close. So I'm going to try to show up and see some ants beat each other up. And if anybody wants to join me, that's fine. You might want to read on there that place has walls, doors, and probably some power. It's got no water really and no something else. It's basically a big old empty building where they got some space to beat some things up on. So anyway, that's all I had on the whole thing. And now, Jesse, after you said all you said, I felt bad. I feel bad that I actually took that Ross question. I should have just shut up and sat down. Just saying.
Well, cool. Well, thanks, Harold. That's we haven't seen that in a while.
I know it's not our thing because we're usually running around doing autonomous, making them smarter so they can take over the world and stuff. But these are basically I don't really call these robots. I call these fancy rock'em sock'em RC cars.
Yeah,
You know,
I just haven't seen them around here since, I think last I saw them was when they ran at Mike's Hobby Shop on 35.
ah,
But that might have been a different group. But anyhow,
you know,
There's a competition coming up in Colorado, and then every weekend in Vegas, they actually have the battle bots actually fighting every weekend.
yeah, Pong keeps me informed on that, and sometimes they get battle bots, depending on the season and what they're shooting. Whether you see the AAA leagues or you see the stuff you see on TV.
Yeah,
You know,
the big stuff is going to be in the first quarter next year. I don't know the exact date, but the competition, the actual battle bots competition, will be sometime early next year.
yeah, it's a lot of fun, man. And we have a couple teams around here. We have Sub-Zero, we have Switchback, and there's one other that have shown up in the big leagues on TV. So some of that's kind of fun.
I think you got to be careful. The address on their website is wrong. The zip code is not 75052. It's actually what it is in the flyer, which is 75007.
Oh, there you go.
Yeah. So
leave it to our high seas to correct that. Way to go, Carl.
well, I drive by that place not infrequently. It's not far from me. It's not far from where the plane crashed in Plano this evening. So yeah.
I didn't hear about that, but
yeah, it's a small, one of these community, like 5 or 10 homes on the airstrip out by Stonebridge, the Home Depot at Plano Parkway, and the plane came
over
down.
by the mall.
Yeah,
Wow.
yeah, it's right across from the Home Depot and
across from the mall.
I got to, but yeah.
Wow.
Sounds like the pilot died, but no fun.
that's no fun.
Yeah.
No fun at all.
So there used to be an airport right there at like Midway and Spring Valley, maybe?
I think that's what we were talking about. It's
well,
almost across from the mall, sort of cat a corner from that mall up there.
So
Spring
is it-
Valley and Midway is the Addison Airport. That's
Right.
that's an executive airport. The one we're talking about is basically an airstrip that 5 or 10 private pilots use.
And there are a couple of houses around them that essentially they have houses
Home
around
Depot on one side, houses on the other, apartments on the other, Costco, strip mall, and a diner, which parking lot was used for crash landing tonight. So, all right. Anyhow, so John, I think we had you next,
Okay.
then Doug D, and then off the recording, Jesse.
Okay. In that case, let me pick a window. So I found this, a nice little gripper collection that seemingly you can attach to this. So this actually looks pretty good. And that they have different types, and this basically streams together. So that looks like a very good design. So I would recommend, if you're especially for the upcoming contest, you might want to look at the gripper. It looks like a nice one. Because on the base, and they have different types. And then the other thing was, since we're speaking of demos and whatnots, there's a PI Raspberry group that's going to have a demo on that over at on the side.
Yeah.
Over in Richardson. So those were the two things.
Yeah, if you could put the links in there, that'd be awesome.
Okay, I will try to grab that from this. So those were the two things I wanted to mention. Main thing was the gripper was a neat gripper with the way the base works, and then the Raspberry, because especially with the Raspberry, I think you can use Raspberry with regard to the TED and the card thing, if I remember right. The ROS runs on Raspberry, or it can. So I'll put the links in the chat. That was my thing.
Cool.
That's kind of interesting. That gripper, it looks like a parallel gripper.
Yeah, it's parallel. That's why I said basically it's trees together, and they have different parts that you can put between the pincher, basically.
Do they? What is? Am I looking at a product, or is this a design?
The top has interchange. Okay.
The Thingiverse project, right?
It's a Thingiverse. In this case, they have multiple gripper tops that can go onto the base, and the base is actually. I think that'll get me to there. Let's see, so the actual base of that gripper looks like that. Oh, there it goes.
Missing child or something?
Kyle TX. Gold 2010 Toyota Highlander Texas license plate 9DB2390. Victims are 6-year-old with F. Jalen Weber Daniels and 6-year-old with F. Jordan Weber Daniels.
Okay, so John, we're
6-year-old with F. Highland Glasgow. Call 911 with information.
Unfortunately, I can't get to that. Family show. So back to So here's the parts for the base of the gripper. You can see where basically you use a servo, and then they pinch it effectively up here, and then they have the different types of grippers that can on the top. So there's another view.
So do they use a rack and pinion?
Yeah, well, let's see if we can get a better picture of how exactly they do it. I think they use the rotation type thing. Right there, I think, is how they, effectively rack and pin. I think that's your, there, and then your two pieces are there. Number 12 and 11. So let me click a little further down. You can see the little grooves there behind there. So
Go 3D on that one and rotate it.
I can't. I'm in Thingiverse. I can click for the next page.
Oh, you can't. It doesn't have a Thingiverse. Usually has a 3D.
Where?
Go back up to the image.
So it does look like.
Whoa! Go up. You're rolling down. See that little 2 arrows? I think that's it.
It says 3D right there to the right, actually. But you have to get the right one.
There you
go.
There's something new. Okay.
Okay.
How do you get?
Just use your mouse.
You should be able to rotate it and everything.
Yeah, but there's the one we want to.
Yeah, there it is. Okay. Yeah, rack and pinion.
Yeah.
Okay. Well, it's still cool. It's a nice compact design.
Yeah, and as I said, what was it to me was the fact that the top part, they actually change out the top to a couple different variations there.
Yeah.
This one right there in the center would look like a perfect one for a can.
Yeah.
I'm thinking.
Yeah, well, if it wasn't, you can design it to make one.
Make it a little larger, yes.
Yeah.
That's why I'm like, when I saw that.
Oh, can you go down and see, just for scale, is that a standard size servo? What does it say in the...
servo. Servo more details, screws. NG995.
Okay, that's a standard. Metal gear servo. Okay, cool.
So that's why I said especially that was for the can contest. And then the other one was regard to Raspberry in general. The fact that they're demonstrating the 5
Yeah. Has anybody got their hands on a 5? Jesse, I bet you have. Have you got a 5?
Not yet. I been focusing on my rover, so I've been
Okay.
using my Xavier. So I
Yeah, I
haven't
thought-
gotten the Pi 5 yet.
Yeah, I thought maybe SparkFun would.
They're back ordered.
Yeah, I know. I got mine ordered with SparkFun, so I'm waiting for it.
Well, the president of Pi was there and actually had a discussion with them, so they're definitely going to get them. It's just a matter of supply.
Yeah.
Hanging out with Even, huh? Even Upton? Cool. Cool. I'd like to meet him one day.
Okay, great. So, John, I found the links. Okay, good. You put them in too. So,
Yeah. They
but
probably
don't-
are a better format, but yeah.
Mr. Doug D, what you got?
So I sent off for this, which is not a really good way to see it. It's that motor controller we were talking about last time.
Yeah.
I'm going to present real quick because the picture on the web is a whole bunch better. You should be seeing my Amazon order for that DC motor driver.
Yeah.
And so that's what we talked about last time to replace my L298. I've got them in and I'm going to be hooking them up, but I have no report yet to show. I have to change my hookup stuff because it takes a 5-volt input and an extra ground and these pins right over here to make that work right. So it's a little bit different connection thing. I have to do a little bit of extra wiring, and then hopefully by next week, if I'm here, I will be able to demo it actually rolling. It looks like it'll be a little stronger than what I was using before. So that's all I had.
Okay.
I'm going to be taking off any minute now. I'm sorry, I can't wait for that other very interesting topic, but my wife's trying to make cornbread and we're out of baked buttermilk. I got to go get it.
You got a honeydew. Those take priority.
So be happy. See you next week.
See you later. Thanks. All right. That takes us to open mic for recording, and then if not, then I'll end the recording and we'll go to Jesse and call it a night. Any other open mic items? Okay, so we'll stop the record here, and then here's some magical secrets. Let me just hit pause. Here we go.